With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, welcome to Doubtnut. So we have some statements here in the question and we have to state true and false for the statements. So let us read the statement first. So our statement 1 is law of conservation of mass is valid in nuclear reaction. We have another statement, that is statement 2. In statement 2 it is written on dilution normality of solution changes. And finally in statement 3 we have molarity of solution does not depend upon the amount of solution. So we have to state whether these statements individually, each of them, are true or false for the above statements. So let us see all the statements one by one. So first is statement 1. So in the statement 1, the statement is law of conservation of mass is valid in nuclear reaction. So first of all, let us understand that what is law of conservation of mass. So law of conservation of mass tells us that the mass of reactants that we take in a chemical reaction, mass of reactants is equal to mass of products. That is, how much mass of reactant we take, we will get accordingly the mass of products, and mass never gets mixed, or in scientific language, mass is never destroyed. Mass is never destroyed. That means if we have taken X amount of reactants, supposing we take X amount of reactants, in the product side, that is mass wise, this is X gram, we will always get the weight of the products will be X gram of the change products, and if any of the reactant is remaining, that is the mass on the product side or mass after the completion of chemical reaction will always be X gram. Now let us talk about nuclear reaction. So nuclear reactions are some special reactions. Nuclear reactions are special reactions, and in this case what happens, some mass gets converted to energy. Some mass gets converted to energy, and this is given by a very famous equation which was given by a very famous scientist named Einstein, that you must have heard of. He gave an equation where he justified that E is equal to mc square, that is energy is equal to, the terms meaning are E is energy here, that is E is energy here, and m is the mass here, m is mass here, and c is the speed of light, that is 3 into 10 to the power 8. So what happens that in nuclear reactions some mass gets destroyed and it is converted to energy. So the missing mass or the change in mass, that is the difference in mass, is this mass, that is the destroyed mass, is taken and it is converted into energy in a chemical reaction. So our statement 1 is false, that is law of conservation of mass is not valid in nuclear reaction. So law of mass conservation is not valid in nuclear reaction. So statement 1 is false. We must write here statement 1 is false. Why? I think you have understood it well now, that some of the mass is converted to energy, and that is why the mass of products is not equal to mass of reactant. That is, mass of product is not equal to mass of reactant in nuclear reaction. So this is the first statement. Now let us talk about the second statement. So our second statement says on dilution normality of solution changes. So let us analyze the second statement also. So we have statement second, which talks about dilution of solution, and we have to tell what happens to normality here. So first of all, for this we have to understand that what is normality. So the formula of normality is normality It is a unit of concentration. It is a measure of concentration. Normality N is equal to grams of solute, that is mass of solute in grams, grams of solute divided by volume of solvent divided by volume of solvent. You must remember here that is not the solution here, it is a solution, into equivalent weight of solute. So since we are taken in concentration the volume of solvent here, that is normality, is inversely proportional to volume of solvent here. Hence normality will change on changing the amount of solvent. So normality will change on changing on dilution. Dilution means increasing the amount of solvent. So normality will change on increasing the amount of solvent, because per unit solvent the weight of solute will decrease. So our statement 2 is, let us see the statement 2, on dilution normality of solution changes. So this statement is true. So statement is true. So our second statement is true. Let us write here statement, this was statement 1, this is statement 2, it is true. Now we have only one statement left, that is the third statement says molarity of solution does not depend on amount of solution. So let us analyze this solution, this statement also. So they are saying in the statement 3 about molarity. So for this, first of all, let us understand that what is molarity. So molarity is equal to moles of solute, that is number of moles of solute, divided by liter of solution, that is volume of solution in liters, volume of solution in liters. Now our statement says that molarity of solution does not depend on the amount of solution. So we can clearly see that volume of solution is included in the formula of molarity, that is molarity is inversely proportional to volume of solution. That is, if volume of solution will decrease, molarity will increase, and if volume of solution increase, the molarity will decrease. That is, when molarity increases, volume of solution must be down, or when volume of solution will be increased, so molarity will be decreased. So our statement 3 is also false. This is a false statement. So your answer for the third statement is statement 3 is false. So these are our answers for all the three statements. We have analyzed all the three statements based on the facts, and these are our answer. Statement 1 is false, statement 2 is true, and statement 3 is false. I hope you have understood the concept well. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.